it gets to you a little bit. I just realized I'm not recording. Oh, my goodness. Yeah, sometimes. I think it depends on the shape, definitely. Interesting. Yeah, interesting. And it's important to look at that, you know. Sometimes what might work for one type of instrument might not work for the same instrument, just a little different style. Because it's got to be the same. You guys are all musicians. That's so cool. That's super cool. Cool. We're getting it there. Okay, so sometimes different images have many different lines of symmetry. How many lines of symmetry does that square have? What do you guys think? Can you draw it in there? 4, Isaiah says. Let's see if he's right. Can someone draw the lines of symmetry? Parker says 4. Because you'll have to draw in some lines of symmetry there.
No, it has like, it has a lot.
Good stuff, you guys. Which one has a lot, the square or the dreadnought guitar?
Oh. What?
Which one has a lot of lines of symmetry?
The square.
The square, yeah. Yeah, sure does. Very good. And you guys are right. I like how quickly those got drawn in there. That was super cool.
Wait, isn't there technically like a lot? Because you could like go like this, and then it's kind. Wait, is that no? Never mind. That's not.
Yeah. No, that's a really good question, because you're like, is that one of those shapes that technically there could be like so many lines of symmetry? And it all depends on where you fold it. So the square only has 4, but there.
I think you're thinking of a circle.
Yeah, I think you're thinking of you know, a more circular type shape. You could even, that's where Google comes in. So you could even Google. It's really cool to see it. I don't know why this stuff fascinates me, but lines of symmetry and shapes. So you could even Google image it, and they kind of show you. Yeah, definitely with a circle, there's a lot. Shows you different charts, hexagons, octagons. They're going to have a lot of lines of symmetry. A star, that's kind of a classic one. That, where's the star?
So it really just depends on the edge.
It does, yeah. And if the edge has a matching edge to match up with. So there's kind of a star. So it's kind of neat, and it's helpful to Google it and see where, you know, where different. Sometimes they'll give you like an H or a cross. Those only have 2 lines. So interesting. Good stuff, guys. Love the input you guys give. Very good. Okay, we're going to talk about translations. A translation is a transformation that moves all the points in a figure the same distance and in the same direction. So it's like a slide. And what you guys will have to do is you'll be given like a point on the coordinate plane, and you'll have to translate it different ways. And there's a few ways to do that. So in this one here, this problem says, what are the new coordinates if the point, it says points, but it's just point, -2, 9 was translated to the left 3 and down 5. What do you guys think we should do? First thing, just to help this problem get infinitely easier, what's the first thing we should do? If we're given a point on the coordinate, draw it. Yeah, you're totally right. Draw it out, my friend. It will help so much. So we'll draw it on the coordinate grid, a thing with the stuff and the yeah. That's what you could do. Okay, so where would -2, 9 be? And remember, we can always use these little marks here. I have 2 kitties on my bed now. Both cleaning their butts. It's kind of weird. I'll stop drawing stuff because I know you guys were kind enough to do that. I'm going to extend this line up a bit further. Oops, sorry, I'll go back. Did not mean to do that. Okay. So we got to sketch the point. Boom, all the way up there. We got to sketch the point -2, 9. Where would that be? Where would that be? What do you guys think? Guys, remember with our plotting, we've got the horizontal x. Yeah, very good. This is the horizontal axis. It's x. Remember, this side is the negative x side. So if we got to go to -2, 9, yeah, you got it. Very good. Remember, all of these ordered pairs, this is called an ordered pair or a coordinate point. They're always in the form of x comma y. So the x is always first. And this would be a really good thing to write down if you forget it. Okay, this is a really good thing to write down because it confuses people. It really does. So the -2 goes with the x and the 9 goes with the y. So then we start in the middle. What's another word for the middle of the coordinate graph? The center, yep. Starts with an O. 0, 0, yep. No, not that one. The origin, very good, Parker. Yeah, very good. Yep, it is, and Kira, that's a good point. It is 0. That's where that is. O for oval. No, no, no. It's the origin. It's where you start. So you start in the middle, and if x is -2, you're going to go to the left 2, and then y is a +9, so you go up. Always for center. Yes, it's very good. I like that. So -2, 9. So that's our original point. Now what we got to do is we have to go left 3 and down 5. And now that we've drawn that, we can really see where it would be. So if I'm going to go left 3, yep, and then down 5. Good. We're right here. That's so good. Where would that point be? Where is that new point? And here's where it's kind of hard to count it out, especially if you kind of sketch it. But if here was -2, okay, let's check it. Yeah, and it's kind of hard to see because we sketched it out. So here's what's tough. Okay, yeah, let's check that. So we were at -2, and then we went left 3. So then it's -3, -4, oops, and -5. So we're actually at -5 on the x-axis. Remember that x, we're in the negative x area, so that x is well, actually, it should be that -4. I think you guys are confusing. What did I just fling over there? You guys are confusing yeah. If you just looked at it, Parker, it looks like it's about -4.6, but it would actually be -5, because watch this. Watch this. If this was our original point, if we go left 3, that means we go more negative. So we actually subtract 3 from that x. -2 minus 3 is -5. And we went
good at plotting without the squares and the graph.
It's hard. It's hard to see it. Yeah, that's why it helps to do this part where you might actually subtract it. If you go left, you just got to subtract 3 from that x. And if you go down 5, we're going to subtract 5 from where? Where do I subtract that 5 from? Yeah, Kira. Very good. Kira's got it. It would be the 9, yeah, which is the y. Very good. So we're at -5 and 4. That's where we're at. Because it's hard. You guys are totally seeing. It's hard to see that. It really is. So if you go left, you subtract from the x. I knew it. That's what I saw. It's all good. If you go down, you subtract from the y. Let's try that again. Yeah, I saw it. I did. Okay, we want to move this whole triangle left 2, down 5. How do I do that? How do you move a whole figure?
Oh, just move it.
Just move it. Just like move it over. Get out of here, triangle. No.
You gotta, like, whatever you do, you add or subtract to the numbers.
Yes, Vivi, you got it. And what am I going to do that to, though? I'm going to give you a little hinto for my friendzo. Pick it up, Parker.
Doesn't it depend on where you're moving it to?
Yeah, it kind of does. And I think first it helps to know what we're moving. Put your back into it, right? So what we're moving, so if we want to move this whole triangle, we're not going to focus on lines here to move because that's too hard. We're going to focus on the vertices. Kira, you got it. Very, very good. It's the vertices of the triangle that we're going to move. Or the corners, the points on the corners of the triangle. Yeah. And we're going to do what Vivi said. We're going to add or subtract depending on where we're going. So if A was at 1, 1, okay, if I'm going to go left 2, so any left or right movement goes with your x, and any up or down movement goes with your y. So we go left 2, does that mean we're adding or subtracting?
Adding. I don't
Left.
know. I get confused with the directions.
Yes.
Left 2 would be subtracting.
It would be subtracting. And here's why, Vivi. Here's how you can kind of keep it straight.
Left. Oh, I thought you said right.
Oh, yeah. It would be left 2. If we went right, we would add. But left means you go, and if you think of a number line, anytime you go to the left on a number line, you're getting more negative. Yeah, she's on fire. Woo! Go, Kira. So we're going to go left 2. Oh, yeah. Oh, very good. Isaiah, that's a good one.
He's actually wrong, though.
Oh, yeah. Lefty. It would be righty-tighty, lefty-loosey.
Lefty-tighty, righty-loose.
No. Righty-tighty. So you get tight, you get more positive. I don't know. So, okay, so we go left 2, so we subtract 2 from that x. And now we're going to go down 5. So we're going to do what with that information? What do we do?
Go down.
Go down, yeah, but how do I take that into account to the point? What do you think? If I went left 2, I subtracted 2 from the x. So if I go...
would it be subtracting again?
Yup, from where?
From the y.
The y, yeah, you got it, my friend. Very good. So x is the first one, y is the second one. So we're going to go down 5, so we subtract 5 from that y. 1 minus 2 gives me -1. 1 minus 5 is -4. So that tells me A should be at -1 -4. And since it's a image that I moved, I call it A prime. This little thing means prime. That's what you get after you do a movement like that, A prime. Okay, let's focus on the B. Okay, so B is at 2, 3. There's a B. It's at 2, 3. And we're going to do the same translation. So we go left 2, down 5. So what do I get for my new point for B prime? What would that be? What would my new point be?
0, 2.
0, negative.
-2. That's
yeah.
what
I knew that's what you meant. I knew it. That's what you meant. And see, if you said 0, 2, you would always plot it and be like, wait a minute, that's not right. So, that's a good way to check yourself. So 0, -2, there's B prime. Good stuff. It's not too bad. It's just different, like I said. So C is at 4, 1. So we're going to do the same translation. Left 2, down 5. Where would C prime be?
Oh. 2.
Yep.
-4.
Yeah, very good. Can someone plot that for me, please? Very good, Kira. You got it. Woohoo! We're on the C point. Sorry, I didn't write that one. I should have written it. I was lazy and I used what was there. Yes, but that's right. So you would be at 2, -4. So we have C prime. Very good. And then our last step, we would draw in those lines there to move our triangle. And you can kind of check it. You can always check it. So A should have moved 2 left. So 1, 2, and then down 5. 1, 2, 3, 4, 5. So you got like 2 things you can do. If you're a little uncomfortable with the subtraction, you can always, you could even Google image a grid and have it right on your computer. And you can use there's a lot of different screen readers you can get. And I have a few I could recommend. My favorite is Epic Pen. That's what I recommend. It's a good one. So cool. Any questions on this? Epic. Any questions on that? That's more confusing, so I don't think we're going to go through that one.
How do we remember which one's A and B and C and D?
Oh, on the figure here?
No, like on the graph thing. How do I know which section is A and which one's B and which one's C?
Well, we just go by what's labeled. So it'll always be labeled when you have to move it. So like if they want you to move A, B, and C, we need to move every single one of those points this translation. And you're only going to move points. We don't move lines. We move the points and then the lines come after. So you could go completely out of order. Doesn't matter. You would just pick every single point. And here you see it labeled. So this corner of the triangle is A. So we just go by that corner. And that becomes our point that we move. And then oh, go ahead.
Isn't there like a thing where it's like A, B, or is that with numbers?
Oh, the quadrants. You're thinking the quadrants. Yes. Yeah, we would say this is quadrant 1. Oh. This is quadrant 2. This is quadrant 3. Yeah. And then this is quadrant 4. And they always put it with Roman numerals just because there's so many other numbers on the grid. So, yeah, it goes counterclockwise. But I'll have to say, you guys really, you know, it's something to know, but you don't really, I don't know. You're never going to be like tested on the quadrants, you know. So if you forget, that's okay. Just Google. Google is our friend today, just like Desmos. No. Okay, so the last translation that we're going to talk about is, transformation we're going to talk about. Transformations are all of these movements. Translation is the slide. We're going to talk about a flip or a reflection. A reflection, you guys know that, it's a mirror image, right? Every point is the same distance from a central line or from that reflection line. Okay, so in this question here, they want us to find new coordinates if every point is reflected over the y-axis. So that means that every point should be the same distance from the y-axis. Okay, so we're gonna imagine, and you can kind of draw it in if it helps you, but imagine that this y-axis is your mirror. That's where the mirror is being laid down. Okay, and on the other side of the y-axis over here should be that flipped image. So we could do it a few ways. Hi, Dawn.
Hi, I don't want to interrupt, so you guys
No,
keep working.
we're good. We're gonna finish talking about reflections and then we are good to go.
Perfect.
So, okay, so we gotta flip this A over that y-axis there. And we notice that that A, yeah, very good. That's where it goes. Totally. The A is one space away from that reflection line. So A prime goes over here. B is 2 spaces away. So B prime is over here. C was more spaces away. 4. 1, 2, 3, 4. Yeah, 4 spaces. So C prime goes there. Very good. Good stuff. Now, see how B was at 2, 3. What would B prime be at? Math man, Isaiah. Very good. I like that. What would B prime be at? -2, 3. Good job, Kira. Yeah, -2, 3. So the only thing that changed is we flipped the x's into the negative part. So the x's go negative. So when you reflect over the y-axis, the x's go negative. Okay, so I have some handy dandy rules for you guys for if you reflect over different areas. And again, you can draw it. You'll have to draw in, there'll be like a Poodle question on the Moodle part, but I don't think you really will have to draw in Math Excel. I think it'll just be like saying what the new points would be. So it would help.
What does Poodle mean?
Poodle is those drawing questions that are in Moodle. That's what
Oh,
those.
it's paint Moodle.
Yeah. That's right. Good questions, you guys. So these are the rules. So see what we just found out. Well, oh, sorry. Go back. So what we just found out is if you flip over the y-axis, it makes your x's turn opposite. So even if we were in the negative x-axis area, even if we were over here, if we flipped it the other way, our x would go positive because we're going into the positive x area. And then if we reflected over the x-axis, it makes your y's go negative or opposite of whatever it was. If you reflect over the origin, both of them go negative. I don't think you'll have to worry about this one here, over the line y equals x. I don't think that shows up. But that is the rule. And I did get this right off of Google Images. So if you don't write it down now, you can always go to Google Images and type in reflection rules. And this will pop up. So, does anybody have any questions about reflections? Any questions? If you have no questions, go ahead and write nope in chat. Just so I know you're with me there. Cool. Okay. Thanks for your awesome input today, you guys. You guys are awesome. Dawn, this class is amazing. So amazing.
Yeah. I just, you haven't seen the email that I sent out, Jen, because you're teaching, but I'm on a school counselor listserv, and I just want to share this with you guys because it just came through. And the counselor wrote, let me find the email because it was interesting, but it was also like, oh my, it was eye-opening. She said, does anyone have a graphic or / handout tool that helps students organize their online assignments? My students shared that it is difficult to keep each course, which online tool the teachers are using, and their various login information and assignments organized. I just thought, wow, you guys are so lucky that you have the academic snapshot, because some of your peers do not have that.
Oh my gosh, that would be crazy.
Isn't that crazy to think about? Yeah. I feel so bad for those kiddos that are trying to figure this all out.
Yeah, we're doing it with my kids. There's like, we got emailed a page this long with all these different logins, and they're all different. And it's like LD201597, and I'm just like, ah.
Yeah, it's amazing. I mean, it's really tough, but.
Dawn, do you want me to record should I stop my recording? Or?
Yeah, you don't have to record it, because if anybody's not here, I will reach out individually to students. Or